Welcome to Trigonometry section 4.2 and 4.3 on amplitude, reflection, and period, as well as vertical and horizontal translations. Now, we're going to be looking at graphs of sine and cosine, which have been changed in the following ways. And the key to graphing them is identifying the characteristics based on each of the equations. So here's the form that you're going to have to put to memory and identify. You have a times sine of the quantity bx minus c plus d, or y equals a times cosine of bx minus c plus d. And each of these is similar to the original parent functions, the graphs that we looked at in the previous lesson, y equals sine x or y equals cosine x, with the following changes. So the absolute value of a, the coefficient on the outside, is equal to the amplitude. So traditionally, we know the amplitude for both sine and cosine is equal to 1. Now we're changing things up. The period is equal to 2 pi divided by b, provided b is greater than 0. If it's not, I'll show you what to do. Phase shift. Phase shift is a horizontal shift, and it's equal to c divided by b. We'll talk about how to find that. And then vertical shift is the constant that's being added or subtracted outside. If it's a positive number, the graph shifts up. If it's a negative number, then the graph shifts down. Also notice, if a, the coefficient in the front, is negative, if it's less than 0, then the graph is reflected over the x-axis. And an interval containing exactly one cycle or one period can be found by solving the inequality. 0 is less than or equal to bx minus c is less than or equal to 2 pi. That's one approach. I don't do it that way, so I'll show you my technique, but if you've seen something else that you're more comfortable with, feel free to use it. Okay, here we go. So determine the amplitude, period, phase shift, vertical shift, and sketch the function. And then keep in mind, anytime you're asked to graph, you want to include at least one period, which means 5 points. Okay. This doesn't look nice. Let's rewrite it. Everything needs to look nice, right? Good. Here we go. So first things first, the amplitude. Well, what is a equal to? Notice the equation is y equals sine of 2x. A is the coefficient in the front, which is still 1. Okay, so a is 1. The amplitude, remember, is the absolute value of a. So the absolute value of a is absolute value of 1, which is still 1. So nothing changed. Now notice here we have a 2 in front of the x. That's what b is equal to. b is equal to 2. And then, as was listed up above, the period is equal to 2 pi divided by b. So that means the period for this function is equal to 2 pi divided by b, which is 2. So that's just pi. And then this will not change. The step is equal to the period divided by 4. So for this graph, the period's going to be pi divided by 4. Okay, there is no phase shift and no vertical shift. Why do I say that? Well, notice here, I simply have 2x as the argument. It's not 2x plus something minus something or whatever going on. And there's no additional constant being added or subtracted to the entire function. So just make mention, that way we know that you thought about it and addressed it. So there's no phase shift and no vertical shift. And don't worry, we'll do some where there is a phase shift and a vertical shift, but one thing at a time. Okay, so now it's time to start graphing. And let's put in our axes. And since this is a sine graph, the graph of sine of 2x, I'm going to think back to the original graph of sine, okay, and then count out using the step my 5 points. So we always start at 0, and then the step in this case is pi over 4. So keep adding pi over 4 until you get one full period. So 0 is going to be my first point on the x-axis, add pi over 4, Add another pi over 4, that's 2 pi over 4, which is pi over 2. Add another pi over 4, that's 3 pi over 4. And add another pi over 4, that's 4 pi over 4, which is pi. Those are my 5 x values. 1, 2, 3, 4, 5. Now let's go ahead and label the amplitude on the y-axis. It's just 1. So we're going to go up to 1, down to -1. And then now it's time to come in and fill in the points that are actually on the graph. So thinking back to the original sine curve that we graphed in the previous section, or think of your unit circle. Sine of 0 is 0. So sine always starts in the middle, right here at the origin. Then when you count over one step, it goes up to 1, back to 0, down to -1, back to 0. That's always the pattern. 0 up, 0 down, 0 up, 0 down. This is one period. See how I have 5 points right here? And that's enough. So we're going to connect them all. Make sure you don't draw it too straight. It's a curve. And put arrows on the endpoints of your graph. All right, they didn't ask for it, but let's go ahead and do the domain and range so we get in good practice because we'll be asked for that later on. The domain is always going to be all real numbers, so -infinity to infinity. That means the same thing as all real numbers. Just start getting used to using interval notation more. Now, what about the range? Remember, it goes in increasing order. So you give the smallest or the lowest number that is going to be part of the range first. So that's -1, and it's included all the way until +1. And that's it. So that would be a complete answer. Perfect score right there. All right, cool. Let's look at another one. This time we have y equals 2 cosine of pi x. All right, now the amplitude equals the absolute value of A. A right here is 2. So absolute value of 2 is 2. Notice B is equal to the coefficient of x, which in this case is pi. So that means the period's always 2 pi divided by b, so 2 pi divided by pi. Pi's cancel out, bam, bam. So the period's just 2. So when we scale the x-axis, we won't have multiples of pi in it this time. That happens sometimes. The step, you always find the step the same way. It's the period divided by 4. So that's going to be 2 over 4, so 1/2. Again, there's no vertical shift and no phase shift. Nothing's being added or subtracted. Okay, so basically this is a 4.2 problem because we're just doing amplitude, reflection, and period changes. All right, so time to start building our graph. The step in this case is 1/2 and the amplitude is 2. So here's our x-axis, here's our y-axis. We always start with 0 being our first x value if there's no horizontal shift. Well, let me straighten this guy out. Much better, okay. And then the step is 1/2. So I'm going to add 1/2, add 1/2 again, we're at 1, add 1/2 again, and add 1/2 again, and now we're at 2. If you look, and you want to make sure that you did it right, okay? I have 5 points here, yes? 1, 2, 3, 4, 5. They should take you through one entire period. And look, you can confirm the period was 2. We started at 0, we ended at 2. So that's just a little way that you can check and make sure you did all your fractions and everything right. And then in this case, we know the amplitude's 2, so we're going to go up to +2 and down to -2. Now pay attention, this one's cosine, right? 2 cosine pi x. So we know at 0, cosine starts up at the top. And since the amplitude is 2, we're going to start the graph at 0, 2. Then it comes back to 0, down to -2, back to 0, up to +2. And that's it. And then just fill in the rest of the curve. We know what the shape looks like. Make sure your arrows go the right way. Don't draw your arrows going upward because the graph will not go higher than 2. Okay, so don't draw deceiving arrows. All right, the domain, all real numbers. That's always going to be the case. What about the range? Yes, good. This time the y values are going to go as low as -2 and then up to +2. Perfect. Looks good. Okay, moving on. You're probably desperate to do some phase shift. So here we go. We have y equals cosine of x minus pi. So let's start off. Let's get the amplitude. So I don't see any special coefficient out front, which means a is just 1. Amplitude is absolute value of a. Absolute value of 1 is just 1. The period, let's see here. Do you see a coefficient in front of x? I don't see anything being multiplied by it. That means b is 1 and a is 1. So the period in this case is 2 pi divided by b, which is 1, which is just 2 pi. So we have our normal standard period of 2 pi here. The step, remember, is the period divided by 4. 2 pi over 4, that's pi over 2. And then here is our phase shift. Okay, the phase shift you find by looking at this constant here. So I'm going to write down the original, form. We have y equals a times, this is cosine of bx minus c plus d. Okay, the phase shift is equal to c divided by b. So in this case, ignore the negative, right? You just take c, which is pi, divided by b, which is 1. So the phase shift is just pi. All right, that is a positive value. So you're going to shift, if you want to remind yourself of this, pi units to the right. And I'll show you how to do that in just a second. And there's no vertical shift. If there was a vertical shift, it would look like this. You would have like a +2 or something hanging outside. So phase shift, which is a horizontal shift, if it's there, it's in parentheses, it's grouped with the x. If you have a vertical shift, that's going to be some number outside the parentheses, not near the x, affecting the y values. You'll get used to recognizing it. Let's just list. There's no vertical shift. And now let's start labeling our axes. So since there's a phase shift pi units to the right, instead of starting at 0 as my first key point, I'm going to start at pi. That's the only main difference, okay? So here's my y-axis. Amplitude's still 1. Here's the x-axis, and I'm going to start at pi. Now the step is pi over 2. So here's pi, and then I'm going to add pi over 2 till I get my 5 key points. So that's, pi is 2 pi over 2, so adding another one, now I'm at 3 pi over 2, then 2 pi, then we have 5 pi over 2, and 3 pi. Now to double check that you set the points up correctly, look at your first key point, pi, and the last one, which is 3 pi. The difference between those two should be 1 period. And it is, right? 3 pi minus pi, that gives us 2 pi. Good. Now the amplitude is 1. So let's go ahead and label the y-axis from 1 to -1. And remember, you're drawing cosine. So you're starting at pi. You're not starting where x is 0. And cosine, remember, starts up at 1. So it goes 1, 0, -1, 0, 1. And that's it. Okay, beautiful. What about the domain? Yes, they're all going to be all real numbers for sine and cosine, don't worry. And the range, -1 and 1. Perfect. Okay, very good. Let's look at some more examples. Okay, we've got negative sine of x plus pi over 4 plus 2. Okay, so in this case, notice a is equal to -1. Remember, whenever there's a negative in the front, that means you reflect over the x-axis. That also means the amplitude, remember, if you're asked for the amplitude, it's never negative. It's equal to the absolute value of a, so that's going to be +1 still. Phase shift. Phase shift is equal to -pi/4. Remember, your phase shift is if you have bx minus c, phase shift is equal to c divided by b. And in this case, since we have x plus pi/4, think of it as x minus -pi/4. That's how you want to think of it. So just always switch the sign for that phase shift. Now, lo and behold, look, we finally have a vertical shift +2. How do I know it's a vertical shift? Well, it's outside the parentheses. It's not grouped with the x, right? So that means it's affecting the y coordinates. Phase shift is a horizontal shift that's in parentheses, buddy-buddy with the x. Phase shift affects the graph horizontally because x-axis is horizontal. Vertical shift, up and down, that's going to be outside, affecting the y coordinate. So that means we've got a vertical shift. It's a positive number, so it's equal to 2. That means you go up 2 units. Okay, the period is still 2 pi because b is equal to 1. So 2 pi divided by 1, which is 2 pi. Do you remember where to find b? Did you forget? B is the coefficient on x, so b is just 1. And then that means our step is just 2 pi divided by 4. It's always period over 4, so pi over 2. Okay, so let's start drawing our axes. I'm thinking to myself, since we're shifting up 2, I'm not going to need any really negative y values on there. So normally our graph lives between -1 and 1. Now it's going to live between +1 and 3. So here's the y-axis. And here's the x-axis. I'll label the x-axis in a second. But normally your sine curve lives between -1 and +1. If you add 2, to both of those, -1 plus 2 takes you to +1. And then if you add 2 to 1, now you're at +3. So our graph's going to live in here. Okay, if you want to draw for yourself like a little guide so that you're not tempted to go out of bounds, go for it. And then think of that as your new 0, basically, okay, where y equals 2. Now we're going to have to take care of this phase shift. So -pi/4 means we're shifting pi/4 to the left, since it's negative. So instead of starting at 0, we're going to start here at -pi/4. Okay, now the step is pi/2. So to get the next key point of my 5 points, I have to add pi/2 to -pi/4. So how are your fractions? -pi/4 plus pi/2, get a common denominator with the phase shift. So that's 2 pi/4, right? So -pi/4 plus the step plus 2 pi/4 is 1 pi/4. So that's where the next key point is going to be. Then take that one, add another 2 pi/4. Now we're at 3 pi/4. Okay. 3 pi/4. Take 3 pi/4, add another 2 pi/4. Now we're at 5 pi/4. Bam. And then let's scoot this over. The last one I'm doing in my head, add another 2 pi/4, we're at 7 pi/4. Okay? Good. Let me space this one a little more evenly. Otherwise it will drive me crazy. So here's -pi/4. Okay. Looks good. Now we're going to deal with the reflection in just a second. I'm going to draw the original sine graph, and then we'll talk about reflecting it over the x-axis, okay? So if you were to draw sine, remember our first key point is here. Sine starts at 0. Then normally it would go up to 1, back to 0, down to -1, back to 0, excuse me. So normally our sine wave looks like this. However, it's been reflected over the x-axis. So you're going to flip it like so. So you still start at 0, it's just instead of going up, now you're going to go down. Then back to 0, then you go up, back to 0. So the only difference is you go down instead of going up on that first step. And there's our curve. And it keeps going. So the purple is not part of the final answer. No, no, no. That was just there to help us out. And if you want to leave the little guidelines there, that's fine, or erase them. It's up to you. Now let's list out the domain and range. So the domain's still all real numbers, so -infinity to infinity. And then be careful with the range. So the graph is only ever going to go as low as +1 and then up to +3. All right, good. Let's look at a couple more. Obviously, it gets more complicated when you put all of these transformations in the same problem. So here we have y equals 2 times cosine of x minus pi over 6 plus 1. So amplitude is absolute value of a, which is 2. The period is still 2 pi because b is 1. So that means the step is 2 pi over 4, so pi over 2. We have a phase shift. Phase shift is how much? It's positive pi over 6, so that means you go pi over 6 to the right. And then anytime this happens, I just check to myself, okay, the phase shift has denominator 6. Let me get a common denominator with the step, right? Because you're going to keep adding the step to that number. So just remind yourself, hey, pi over 2, that's 3 pi over 6. And then do we have a vertical shift? We do. This time I can see it equals 1, right? That's being added outside. So the graph's going to go up 1. Okay, so here we go. When you have a vertical shift along with an amplitude changed, I usually take care of drawing my new x-axis that's been shifted and then counting up and down for the new amplitude as well. So we have a lot to think about here. Pretty much everything's been changed up except, they didn't change the period on us. They left that alone. Okay, so we're shifting up 1 unit. X-axis. So up 1, so you can think to yourself, ooh, this is the new x-axis. The graph got shifted up 1. But then also the amplitude's 2. So that means the graph's going to go up to +3 and down to -1. So it lives in between there. So if you want to draw yourself some more dashed lines, just to hold yourself accountable and use it as a guide when you're filling in your key points, it's a good idea. Other thing is phase shift is pi over 6 to the right. So that's going to be the first point I plot of the 5. So here's pi over 6. Now I'm going to add the step to it so I get all 5 points. So I've got 1 so far. We can do the fraction work over here if you need help. So pi over 6 plus the step, that's 3 pi over 6. That's 4 pi over 6, but reduce that. So that's 2 pi over 3. Let me space it better. 2 pi over 3 would be here maybe. Then take 4 pi over 6, add another 3 pi over 6. Now that's 7 pi over 6. So 7 pi over 6. Then take 7 pi over 6. Add another step, 3 pi over 6. That's 10 pi over 6. I'm not writing 10 pi over 6. I'm writing 5 pi over 3. And then I need one more. So 10 pi over 6 plus 3 pi over 6, that's 13 pi over 6. And that's the last one. And I'm going to rewrite 2 pi over 3 in black. Now, do you need to show me all this work with your fractions? No. It's just there if you need it. I honestly do this all in my head. And so hopefully you'll get to that point. Okay, very good. Now, let us see if we can plot successfully from here. We're graphing cosine. The first of my 5 key points is at pi over 6. Remember, cosine starts at the top, sine starts in the middle. So cosine is going to start up here at the top at 3. Then it always goes middle, down to the bottom, middle, up. That's it. Don't forget your arrows. All right, domain. No surprise, it's all real numbers. What about the range? It lives between -1 and +3. All right, very good, very good. Last one. I've got a tricky one coming at you, but you guys are up for it now. You've done so many examples. So we've got y equals 4 times sine of the quantity 3x minus pi over 4. So amplitude is a, absolute value of a, excuse me. So absolute value of 4, which is 4. Notice here b is equal to 3 and c is equal to pi over 4. So the period is 2 pi over 3. The step is the period divided by 4, right? When your period involves a fraction, instead of dividing by 4, just think of multiplying by 1/4. It's much easier. So 2 pi over 3 times 1/4, the 2 and the 4 are going to cancel. And you're left with pi over 6. So the step is pi over 6. We have a phase shift here. Remember, phase shift is equal to c divided by b. So that's pi over 4 divided by 3. Pi over 4 divided by 3, or pi over 4 times 1/3, is pi over 12. So right away I notice, okay, phase shift is pi over 12. Step is pi over 6. Let me get a common denominator. So that's 2 pi over 12, because I know I'm going to have to be adding them together. Okay, anything else weird happening? There's no vertical shift, thank goodness. I think maybe that would be a bit much. Just since we're barely learning this, don't think it's never going to happen. And that's pretty much it. Okay, so let's start graphing. So no vertical shift. That'll keep things easy in the y-axis. And phase shift is pi over 12. That's positive. So we're going to shift over to the right. Okay, good. Good. We'll label the y-axis up to 4. Down to -4. And then first point, we're shifting pi over 12 to the right, so that's going to be over here, pi over 12. Now I have to add the step to it 4 more times. So here we go. So pi over 12, that's the first point, plus 2 pi over 12, that's 3 pi over 12. But that's not what I'm going to put on the axis. I'm going to put pi over 4. Then let's do it again. So 3 pi over 12 plus 2 pi over 12, that's 5 pi over 12. So that's the next one. 5 pi over 12 plus 2 pi over 12, that's 7 pi over 12. Look at us go. And then last one, add another 2 pi over 12, that's 9 pi over 12. Can you do this in your head yet? I hope so. I hope you get there quickly. 9 pi over 12. So divide that by 3, right? And that's 3 pi over 4. All right, good. The graph is going to live between 4 and -4 if you want to mark that to help you. And this is sine. Okay, so sine starts in the middle. So here's your 5 key points. 1, 2, 3, 4, 5. Are you nervous? You want to check we did it right? To check, take the first and subtract it from the last of your 5 key points. So 3 pi over 4 minus pi over 12, that's 9 pi over 12 minus pi over 12, that's 8 pi over 12, and that reduces to 2 pi over 3, and yep, that's the period. Wonderful. See, look at us, we're so good. We make no mistakes. Okay, so we're graphing sine, starts in the middle, so at pi over 12 we plot 0, then you go up, 0, down, back to 0. There you have it. Fill it in, nice and smooth. Don't forget the arrows. Domain, all real numbers, -infinity to infinity. And the range, yeah, -4 to 4. And that's it. So that concludes the lesson. The next one, we're going to look at graphing all the other trigonometric functions. So tangent, cotangent, secant, cosecant, and applying changes as well to their period, phase shift, vertical shift, all that good stuff. Okay, so right now you can just focus on sine and cosine. All right, stay tuned.